In these next two sections, we're going to be talking about dividing polynomials and the zeros of polynomial functions. In this example, it gives us our equation of 4x cubed plus 10x squared minus 6x minus 20. So as usual, go ahead and factor. See if you can factor. It looks like this would be a good case for grouping. So I'm going to go ahead and group these and see if I can factor them individually. So because I'm putting parentheses around this and there's a negative on the outside, I want to make sure I change the sign before I get too far into my, my factoring. So let's look at what we've got. We can pull out a 2x squared from this side. And we can pull out a 2 from this side. But these are not the same. So this one, this method isn't going to get us anywhere. This is one of those times when it would be beneficial to divide by a polynomial. In this case, it's telling us to use x plus 2 as the divisor. And we're going to do synthetic division. So it's definitely my preferred method. Once you learn it, it's so much nicer, so much cleaner than the other method. So we've got our divisor here. Since it's x plus 2, then our value here, they're calling it k. Our k is equal to negative 2, so that's what we're going to divide by. And then we're going to write the coefficients of our problem here, and then make sure you switch this back to negative 20 like it was. So we've got a 4, 10, negative 6, and a negative 20. And then for synthetic division, what you're going to do is you're going to multiply your divisor by the number that you get here. So in this case, we have a 0, so that's going to be nothing, and then add them up, so it's going to stay a 4. Now we can multiply negative 2 times 4, it's going to give us negative 8. Add 10 plus a negative 8, it's going to leave us with 2. Negative 2 times positive 2 is going to give us negative 4. Negative 6 plus a negative 4 is going to give us negative 10. And then negative 2 times negative 10 is going to give us positive 20. Negative 20 plus 20 is going to give us a 0. Since there's a 0 here, it's confirming that x minus 2, x plus 2 is a factor. So we've got x plus 2, and then here are the coefficients of our new polynomial. And then we've reduced it a degree since we've taken this one out. Pardon me. So now we've got 4x squared plus 2x minus 10. So let's see if we can factor this anymore. We can pull out a 2, so that's going to give us 2 times 2x squared plus x minus 5. And then let's see if we can factor this further. So I don't know if you remember this one. We can do multiply that together. So that's going to give us a negative 10. And we need that to add up to be a positive 1. So factors of 10 are 1 and 10 and 2 and 5, and neither one of these is going to make up to be positive 1. So we can't factor it nicely, so what we'd have to do is use the quadratic formula. But in this case, we're not really doing that. This example is really focusing in on what our 0 is. So you can see from this graph here, it looks like it's at negative 2 and that's it. But if you zoom in, you can actually see that there are 2 zeros. So we've got the one here, the one here, and then further, if you zoom out further, you can see you've also got one here. So you could use the quadratic formula to find the other 2 zeros, but we've confirmed that negative 2 is definitely one of the zeros of this function. Now here's a real world example where we can use this. All right, so for this example, it's telling us that the volume of the box is equal to 3x to the 4th power minus 3x to the 3rd minus 33x squared plus 54x. And we also know that volume equals length times width times height. So here, showing us that our width is x minus 2 and our height is 3x. So this equation is going to equal 3x times x minus 2 times the height. So it wants us to solve for h. So what we can do is divide this and find out what the other factors are going to be. So to solve for h, we want to isolate it. So let's divide by 3x from both sides. And that's going to give us, we're going to be left with an x third to the third here, minus x squared, negative 11x, and 18. And now we're going to divide by x minus 2. And that equals h. So now we can go ahead and do this using synthetic division. That's going to be the easiest way to get this. And because we have a negative 2 inside here, we're going to use a positive 2. So we've got a positive 2 here, and then we'll just rewrite the coefficients. So we've got positive 1, negative 1, negative 11, and a positive 18. And again, so you multiply by this number and add up the column and drop it down, and then multiply again here. So 2 times 1 is 2. Negative 1 plus 2 is going to give us a positive 1. It's going to be 2. It's going to give us a negative 9. And then that's going to be a negative 18, which results in 0. So x minus 2 is one of our factors, which we already knew. So no surprise there, but that tells us what's left. That's the most important thing. So what's left is our h. So h is equal to x squared plus x minus 9. And as you can see, this is not nicely factorable. So for this example, we're done. All right, this next section, they've gone ahead and kind of jumped ahead of what we were doing here, but it's showing us what our zeros are. And in this case, we're talking about the rational zero theorem, which says that if we take P over Q, then this is going to be a potential factor for this equation. So P is the factors of the constant term, and Q are the factors of the leading coefficient. So in this case, our equation is 4x cubed minus 3x minus 1. And then our constant is the negative 1. So our P could be plus or minus 1. And then that's going to be over our factors of 4. So our factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. So now what we're going to do is combine every possibility to come up with our potential factors. So P of Q, that's going to give us plus or minus 1, plus or minus 1/2, and plus or minus 1/4. So let's start with positive 1, and we'll see what we can get from there. So we've got our 1 out here. Oh, sorry, I'm just jumping ahead really fast. Yeah. So we've got a 1 out here, and then we need to write our coefficients. And in this one, be very careful because we're missing a term here. So we've got 4 for the x cubed term. We have 0 x squared terms. We have a negative 3 for the x and a negative 1 for the constant. So now we'll bring this down. It's going to give us a 4 here, 4 here, 4 here, 1 here, 1, and a 0. So that's definitely a factor since we ended up with a 0 here. So that means we've got x minus 1. These are the tricky parts, so make sure that you're paying attention to when you need to change the sign. So we've got x minus 1, and then that's times. Now we're going to attach our variables and change, reduce the power since we've pulled out one of the x's. So our 4x cubed, we're going to be left with 4x squared plus 4x plus 1. Now what we can do is go ahead and see if we can factor this. If we pull out a 2, we can't factor it that way, but let's try something else. Let's try this way. So we multiply those two together, that's going to give us a positive 4, and those need to add up to become a positive 4. So that means we've got 2 times 2. So we're going to have 2x plus 1 squared. So we're going to have 2x plus 1 times 2x plus 1. So it's just going to be squared. So that means that we're going to have our zeros at x equals 1 and at x equals plus or minus a negative 1/2. Oh, sorry, x equals, sorry, I've got that wrong. Sorry, it's just x equals negative 1/2. We don't have a plus or minus in this instance because we're just taking what's inside here. This is irrelevant at this point, but it does mean that we've got a multiplicity of 2 at x equals negative 1/2. So that's showing that we're doing that bounce. So remember that shows a multiplicity of 2, and then this one is going to be a multiplicity of 1. And then let's see, with this one, we are looking at we're also looking at the rational zero theorem. So let's look at our polynomial. We've got 3x cubed plus 9x squared plus x plus 3. And then let's go ahead and factor this. Oh, that's right. I didn't like this example because you can actually do it the easy way. So I'm going to show you the easy way, and then we'll go back there and do it the hard way. So you know how, in books, sometimes they pick like this random number to check and it happens to be the right one. Well, that's the magic of them having already figured this out. But there's definitely an easier way to do this. And when you see multiple factors here, drawing a blank on that name, terms, think about grouping. See if you can group it. So let's group these first two and group these last two. In this case, it's a positive, so we don't have to worry about doing anything with this sign. So let's start with the first one. We can pull out a 3 and an x squared. And that's going to leave us with an x plus 3. And then we've got a plus 1 and an x plus 3. So now we can pull these apart. That's going to give us a 3x squared plus 1 and an x plus 3. And now we know that x equals negative 3 is at 0. And then now we need to split up this one. So this one is going to give us, if we set it equal to 0, 3x squared equals a negative 1. So this right here should be your trigger that this is going to be probably a complex number. So divide by 3 and take the square root. So we've got x equals plus or minus the square root of negative 1/3. Just double checking my work here. Yeah. All right, so now we can look at it the other way. So when we're talking about doing division, let's go back to this 3x cubed plus 9x squared plus x plus 3. And let's do the rational zero theorem. So we've got our P's and Q's. Our constant term is 3. So our potential factors are going to be 1 and 3. And these are always plus or minus. And then on the bottom, we've also got a 3. So we've also got plus or minus 1 or 3. So all the combinations, if you can see, is we can end up with 1 over 1, which is going to give us plus or minus 1. We can end up with 1 over 3, so plus or minus 1/3. And we can end up with 3 over 1, so plus or minus 3. So these are all our possible zeros. So this is where in the example, they go straight to -3. I don't know about you. I wouldn't have thought to go straight to -3. That probably would have been the last one, or maybe the fractions would have been the last ones I would have checked. But either way, would have not have jumped for -3. So this saves you a lot of time, but let's go ahead and do it anyways. So if we picked the -3, then what we want to do is take our long division. So we've got the 3 here. Oh, and this is going to be positive since we've got inside the brackets, we've got x plus 3. Oh, no, I did that wrong. That was negative. So it should be -3, and then we're going to write down our coefficients. So we've got 3, 9, 1, and 3. So now we've got 0 here. That's going to just bring us down 3. A -9. It's going to give us 0. Bring down the 1. And -3, which is also 0. So this is going to leave us with a 3x squared plus 1. So you can see we've got our factor here. We had a factor of x plus 3, which we already knew. And then we ended up with the same exact thing, doing it this way. So if you can't factor it nicely, then by all means, use the rational zero theorem, using the possible factors of P and Q, and then using division, synthetic division, and that'll help you also find the roots. All right, now the last one, this is talking about Descartes' rule of signs. So it's there to help you find out how many zeros and what kind of zeros you're going to have. In this case, the Descartes rule of sign is going to tell you whether or not they're positive real roots or whether or not they're negative real roots. So we're looking at sign changes. So we're going from negative to negative, so no sign change, negative to positive. So here's a sign change. And then we go from positive back to negative. So here's a sign change, and negative to negative, so no sign change. So this indicates that there are 2 positive real roots. So we can find those pretty nicely. And then what we want to do to find the negative ones is we want to substitute negative x into our equation and then do the rule of signs again. So once you've plugged in negative x for every x value, you're going to end up with this polynomial. And now we're going to check the signs again. So we go from negative to positive. So there's a sign change. No sign change, no sign change, sign change. So we also have 2. So this means we have 2 negative real roots. And this last one shows you what it is. Oh, and let me clarify. This means we have 2 or 0 real roots. And the reason why it jumps in 2s is because if you end up with a complex number, you're going to have a plus and a minus. So that accounts for your 2 possible complex roots. So that's the reason why it's going to jump. And it's not going to be more than 2. It's going to be either 2 or 0 positive real roots. And then in this case, we're going to end up with either 2 or 0 negative real roots. So here's what we're showing. Here, if we graphed this this polynomial here, we would end up with this curve. And you can see that we ended up with 2 negative real roots and 0 positive real roots. So that's it for these sections. More in the next video.